something exciting and kind of unexpected popped out among the rocks of the Eco Valley in Peru. The bones of a really old whale that lived almost 40 million years ago. At first, no one was really impressed because the bones they found were big and weirdly shaped. So people just thought they were looking at giant boulders. I mean, that's cool too, but things got way better when they realized those were the remains of a very large ancient animal that roamed along the coast of ancient Peru. Plus, it was probably the heaviest creature that ever lived. Sorry, blue whale. I know you worked hard to get to the top. The length of over 100 feet and weight of more than 200 tons brought you the status of the biggest animal on our planet. But it seems you've held the title long enough time to hand it over to our next candidate. And that one's really gigantic. This ocean beast was probably shorter than the blue whale, but heavier with a weight that could be between 93 tons and 370 tons. If it's closer to the higher number, it'll make Peter's the biggest animal ever known to have lived on Earth. And it seems its weight was the result of having extremely thick, dense bones. You can see such bones today in manatees or some other early whales. Dense bones are a great tool for such marine mammals. This feature makes them heavy and allows them to stay submerged most of the time, but at the same time, if their body was too heavy, they would end up sinking all the time, and they would waste too much energy to move back up to the surface. So to avoid sinking, marine mammals need to have enough lighter tissues, like muscles and fat, to help them float in the water without using too much energy. Now scientists didn't have the whole skeleton, which makes it hard to tell how big the animal was. But they add the ratio of the heavy bones to the lighter tissues in other marine mammals to estimate the overall weight of this giant ancient whale. Experts found these fossils about 13 years ago and spent the next decade freeing the whale from the rock. Its anatomy and age showed this whale was a cousin of Basilosaurus, a whale that had a long snout full of sharp teeth and a sleek body similar to that of an eel. Even if Perucetus wasn't bigger than the blue whale, it was still a giant that ruled the ocean depths. Unlike modern whales, there's a possibility that this ancient fellow was a predator that liked to go after bigger prey. And this also changes how we see the history of whales. Scientists used to think these magnificent creatures became really big about 5 million years ago, when they started eating lots of small creatures. But here's the proof that giant whales existed even before that. But it's still unclear how this WH managed to find enough food to sustain its enormous body. Plus, it's still hard to tell what exactly this ancient creature had on its menu. It was pretty large and not such a fast swimmer. So it's possible it searched for food in shallow waters. Then it probably ate crustaceans, clams, or some other small animals hiding in the sand. One theory says it was a scavenger, which basically means it mussed on remains of everything that would come its way. It's not so unusual to find marine animals in deserts. Many of these regions used to be covered with water. Anyway, the Sahara in Africa is a perfect example, about 50 to 100 million years ago. This was not a dry desert, but a shallow saltwater body called the Trans-Saharan Seaway. The land is not wet there anymore, of course, but people who lived in that area knew about it because they used to find old shells across the desert. The sea was about 164 feet deep. That sounds enough for a nice swim. Some would say this area looked like modern Puerto Rico, with lots of sun and shallow water. Mangrove forests were a common thing, as well as seafloors covered with mollusks like snails and clams. The marine sediment that was left behind after the sea had dried up is full of different fossils, and the animal that lived in that ancient underwater world didn't look friendly. Plus, they were much bigger than their relatives from modern times. So a regular-sized human would end up as a snack, not even a whole meal. Normally, when animals live on small islands, they can become much bigger than their relatives from the mainland. This is something we call island gigantism, and it happens because there are more resources or fewer predators on islands. Maybe the same thing happened in the Heron Seaway, even though it wasn't an actual island. The water moved in and out, which created little pockets of water, and specific conditions in these pockets might have helped animals grow bigger. So we're talking about giant sea snakes, catfish, and fish that no longer exist today. One had incredibly strong jaws, and the animal used them to eat hard things, and even crush shells their teeth showed. They were fierce predators. Other animal had every reason to be afraid of. They went through some changes when it came to diet, similar to some types of piranhas, and the competition to get to the top of the food chain wasn't a joke. Not when there were also such large predators as sharks, crocodiles, and ancient relatives of elephants. Sahara went through different phases. If you could use a time machine and take a peek at Earth's largest hot desert, as it was about 6,000 years ago, you wouldn't have to struggle with sand and heat. You'd have a nice walk through a green and pretty lush place in the past. People who lived in that area didn't leave drawings on cave walls that showed camels, sand dunes, and scorpions. All those things you'd see in today's Sahara. Instead, they drew crocodiles. That's additional evidence that the Sahara used to have a lot of water and plants enough to support these big yet scary animals. Around 3 billion years ago, Earth might have been mostly covered with water. Today it's about 71% of its surface, but it seems that our planet used to be a giant ocean world with no continents at all. Just some scattered islands. Scientists studied special rocks in Western Australia that formed in a place deep under the ocean called a hydrothermal vent system. To explain this better, it's important to mention two common oxygen types, 06 and 08. 8 is heavier because it has extra neutrons. 06 evaporates from water more easily, and as researchers studied an old ocean floor, they found a lot of 8 more than in today's oceans. This way they realized ancient Earth had less dry land than Earth today. Australia is a good spot to conduct these studies, because a long time ago, it also used to be a beautiful place with large animals and lush rainforests. But as time went by, the land became drier, and Australia had more deserts formed, such as the Great Victoria Desert rainforest remained only on the edges of the continent. What happens with deserts across the globe is called desertification. That's when land that used to be good for growing things turns into a desert or something similar. Our planet changes over time together with its climate. But desertification also happens because of human activities, like mining, farming, and building cities. And when land turns into a desert, it's a problem because it can't support people and animals anymore. Food doesn't grow there, there's not enough clean water, and animals lose their homes. To help with this problem, there's a plan. Many countries agreed to. They decided to work with farmers to take care of the land, fix damaged areas, and manage water better. All in all, to make our planet a better place for life. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the hidden info secrets.